There are two facets to high creativity. One of them is to be able to know what is a fundamental problem, to be able to discover what is a fundamental problem. And the other is to recognize connections between disciplines that don't seem to be connected.
Welcome to the Science of Creativity. I'm your host, Keith Sawyer. That was Professor Arthur I. Miller. He's a physicist, a philosopher, author of the book, The Artist in the Machine, The World of AI-Powered Creativity. He earned his PhD in physics at MIT, and after he had a successful career as a physicist, he decided to change his focus to the study of creativity in science and art. His books show us how great minds think and how new ideas emerge. If you enjoy the interview, I hope you'll subscribe to the podcast and like it and leave a comment. Share it with anyone you know who's fascinated with creativity and art. Now, here's our interview. I'm here with Professor Arthur I. Miller. Arthur, thank you so much for joining me today.
A great pleasure. Always great to discuss creativity.
Well, you are successful, accomplished in many different fields. I know you have a PhD in physics from MIT. You're a playwright. You're an author, multiple-time author. So you're someone who really has experienced creativity across many domains. What would you say is the underlying essence of creativity in your view across those domains?
Those two domains give us different ways of researching creativity. Both drama and science are ways in which we try to understand the world in which we live. To some extent, they're complementary. Plus, there's some some basic level, which they both combine. And indeed, the ancient Greeks believed that all of this, that drama, science, art, economics, etc., were all part of a unified theory, helping us to understand the world in which we live.
So you mentioned that the Greeks had a unified theory of these different disciplines. So I think you have a unifying theory. I've read your books, and you have a very comprehensive theory about creativity. So would you say that? What would you say is the unifying theory?
Well, it has to include both science and drama. Okay, they're both ways of understanding how people think. I wrote my recent play called Synchronicity, which probes the relationship between Carl Jung and the physicist Wolfgang Pauli. I was inspired to do that by a book I wrote called 137. But I never felt I got into their heads in that book. And so I decided to write a play in which I reimagined their relationship, invented dialogue, because there are letters between Jung and Pauli, and we have also Jung's notes from his analysis sessions with Pauli, although he never mentions Pauli by name, as Pauli requested Jung to do. So I invented dialogue around that, and in that way, I believe I was able to draw a deeper picture of these two men who had extreme personalities and extreme problems as well themselves. What Jung got out of this was that Pauli, the relationship started out as patient-doctor in 1931, when Pauli was in a horrible mental shape, and he came to see Jung as a patient, so it began as doctor-patient, and then they became colleagues and then close friends. And indeed, Pauli encouraged Jung to complete his theory of synchronicity, which the seminal paper on which Jung published in 1953 in a book in which he and Pauli, which contained articles by he and Pauli. Pauli's was a Jungian analysis of the creativity of the 17th century scientist and mystic Johannes Kepler.
Right. It sounds to me that counts as an example of exceptional creativity, right? You talk about Carl Jung and a pretty dramatic new theory of synchronicity. What are some of the characteristics of these individuals that you've identified?
Yeah, there were people who went beyond their fields. They believed in interdisciplinarity, namely to investigate the world in which we live from different viewpoints. Now, sometimes the terms multidisciplinarity and interdisciplinarity are used interchangeably, but that's not correct. They're quite different. Multidisciplinarity is like a salad. It's like a fruit salad. You can recognize the different fruits, a watermelon from an orange, from a strawberry. And people who take part in multidisciplinary meetings approach problems from their own viewpoints. But interdisciplinarity is like a smoothie, and it's very difficult to join that club, so to speak. And Jung and Pauli belong to it. They publish papers in different domains. Pauli in psychology, as well as in history of science and philosophy of science, and Jung similarly in psychology with his own breakthrough theory of analytic psychology. So that is one facet that they had in common that most highly creative people have. That is to say, they are interdisciplinary. They approach fundamental problems in a way that takes in different aspects, different ways of knowing.
Right. And of course, these two individuals are experts in two different fields. So their collaboration itself is, would you say, interdisciplinary?
Oh, yes, certainly so. And it was brought about through the conversations they had in the course of Pauli's analysis and in their work. I mean, my play is about psychology, alchemy, physics, and what can happen when two great minds meet.
Right, exactly. And I'm going back to your book now, and it's interesting. I think I would say that your play has a lot of connections with your own writings about creativity, right? You just talked about these two individuals coming together, and I say one of your 7 hallmarks of creativity, which I hope we talk about more later,
Absolutely,
is
yeah.
collaborate, right? This is an example. And then one of your marks of genius is the ability to spot connections. So yeah, would you say that your creativity research influenced your play?
Oh, yeah, certainly. In my play, I bring in more than psychology and physics, philosophy as well, history of science, and so on. So sure, it certainly has. And it has influenced my writings all across the line and in the other plays I've written, and as well as my work outside of physics, which I was originally trained in. But my passion was always for creativity. So I eventually switched fields into a variety of fields.
Right. Yes, that's right. You switched many different times.
Right.
So I was curious about that because you do have a PhD in physics from MIT and you moved on, like you said, you moved on. So tell us a little bit about that trajectory. How did you get from physics to creativity research?
Well, it's a long story. It depends on how much time you have, but I will outline it. In high school, I had a spectrum of interests that included science, military science, history, philosophy, art, and photography. I thought I would go into one of those fields. But when I grew up in the Bronx, if you were smart or thought you were smart, you went into physics, which is what I did. And I got an undergraduate degree at City College, and then a PhD at MIT. And I went on to do research in theoretical elementary particle physics. But my passion was always in creativity. So having tenure, I decided to change my research interest, well, not into Egyptian hieroglyphics, but into something that touched on physics, namely history and philosophy of science, to study how the great scientists discovered their theories. And to do that, I read the original German language. I read the original German language papers by Einstein, Heisenberg, Schrödinger, Pauli, and so on. And what jumped out at me was that the importance they placed on visual imagery. And so I decided to look into cognitive science, and which at that time in the late 70s and 80s, a big problem was how the brain manufactures images and manipulates them. And so I looked at the cognitive science, and at that time also in vogue was the so-called machine brain metaphor. That is to say, the brain acts as if it's a machine. The payoff, of course, went in the opposite direction, that the machine acts as if it's a brain, but that occurs later with artificial neural networks. What also leapt out at me was that these scientists used words such as beauty and symmetry very much like artists use them. So could there be a connection between art and science? Well, so I decided to look into that. Now, the field of art and science, art sci, was just growing at the time. And at that time, most scientists and artists considered it to be a waste of time. But I persevered in it. Since I studied how science progressed and how art science progressed, I looked into how art progressed. So I did work in art history as well. And then a logical extension of my research was to study how machines can be creative. And I've been doing this in an interdisciplinary way, which includes history of science, philosophy, mathematics, etc. I could jump back here and say how I got into this notion how I was captured by creativity.
Right. That you went from being a physicist all the way up to being a tenured physicist. So you've been doing that for quite some time.
Right, I did. But looking back at how I was startled by creativity originally, turned back the clock to when I was a boy of about 11. At that time, I frequented the my local New York City Public Library, which was a magnificent building, chock full of books as well as 33 and a third records, called today vinyls. And I still remember the day I sat down at a chair at a table next to where the stacks were, which stacked up records. And one of them I still remember I caught, and it was a beautiful pencil sketch of a man deep in thought. And so since being a budding artist, I thought I would bring the record sleeve home and practice sketching the image on it. And lo and behold, and it also included the record. So I decided, since I have it, I might as well play it. And I played it, and it just blew me away. It was Tchaikovsky's Fifth Symphony. And so I ran back to the library and borrowed as much Tchaikovsky as I could, and then gradually worked my way back through classical music. But what struck me, the question that immediately came to mind is, how do these people think up those beautiful and powerful melodies? And so I became hooked on creativity.
Right. And you've mentioned visual imagery as one of the connections between art and science. It's easy to imagine visual imagery in art, but how does that work in science?
Well, visual imagery in science comes in where scientists attempt, for example, to visualize an atom as a minuscule solar system. But then it turns out, as research into quantum physics progressed, you couldn't have images like that. In fact, you couldn't have visual images at all. Visual images based on what we perceive in the world of sense perceptions. It turned out that the mathematical theory became a guide for what images of the unvisualizable subatomic world was. And giving up visual imagery was an important part of Werner Heisenberg's thinking towards quantum mechanics. And bringing back visual imagery, the old visual imagery, was actually on Schrödinger's mind when he first wrote down the Schrödinger equation. He wanted to bring back the old imagery, and he was attacked by Heisenberg about this and had to change his mind. Any visual imagery of the subatomic world was generated by the mathematics of quantum mechanics. And that persisted through early theories of nuclear physics, brought about once again by Heisenberg, in which the nuclear force is thought of as being exchanged by particles. And then finally through Feynman diagrams, which to me are more than diagrams. They are a key to what we can visualize in the subatomic world with the limitations on our visualization.
Well, it seems like there must be some similarity inside the mind in the cognitive representations, whether it's art or science. Would that be the parallel, something about the way the mind works?
Yes, certainly. We are restricted by our sense perceptions. Our sense perceptions are processed by our brain, which has limitations, and those limitations are overcome through mathematics. Numbers are the basis of the universe. And numbers and mathematics allow us to understand worlds beyond our sense perceptions.
Right. So is there some relationship between the mathematics and the way the eye works, the visual perception?
Yes and no, because once again, our eyes are part of the baggage that we carry around that's restricted by sense perception. So no, what we see with our eyes is not what is, in quotes, really out there. As Einstein, too, said many times, he was interested in the world beyond sense perceptions. And in this world beyond sense perceptions are elementary particles, gravitational fields, bending of space-time, and so on.
Right. So is this one of the characteristics of great creativity, that you have this ability to perceive some kind of new worlds or new kinds of representations?
Yes, some people catch that idea. Okay, Heisenberg was one of them. I think there are two facets to high creativity. One of them is being able to know what is a fundamental problem, to be able to discover what is a fundamental problem. And the other is to recognize connections between disciplines that don't seem to be connected. Minds that can do that can come upon a notion that what we perceive is not what is really out there. I mean, Picasso also felt that way. That's what his Cubism was about. It's about a world beyond sense perceptions, a world which he realized you can get through by means of science, mathematics, and technology.
Right, right. And when I was reading your book to get ready for the interview, The Artist and the Machine, your 2019 book, and you describe these two things you just mentioned as the marks of genius, the ability to discover these key problems and the ability to spot connections.
Right.
Right. And it reminds me, this is some key findings in creativity research. The first one we talk about being problem finding, this ability to identify or discover new problems, I think is found in every creative discipline. And then the ability to spot connections is, I guess, a sort of conceptual combination, right? And that seems like these two marks of genius, they're pretty closely aligned with the creativity research I'm familiar with. And the first one being what you might call problem finding or problem discovery. And the second one being this ability to make conceptual connections or some sort of connections, probably interdisciplinary.
Yeah, I mean, to me, not many people are capable of discovering a fundamental problem, to a very high degree. I mean, Einstein, for example, realized everyone in 1905 were trying to find a theory of the electron. They envisioned the electron as a shell of electricity. So why doesn't it blow up? Since all parts are repelled from all other parts. And they came up with some very fancy theories. It's some very interesting theories that some of the mathematics of which last today into modern elementary particle physics. But Einstein realized that, as he put it, just 2 years after 1905, when he was still a patent clerk at the patent office, as he wrote, the great men of physics were theorizing out of their depth. I mean, imagine that. And to him, the theory was not what they should be looking for. It's not a theory of dynamics, but a theory of kinematics, a theory of space and time. And everybody else thought that was a total waste of time. I mean, we all know what we all know what space and time is, but what we want to know how to hold an electron together. And indeed, his first relativity paper in 1905 was understood as being valuable for all the wrong reasons. The first half, which contains the relativity theory, most people found quite boring. And we all know what space and time are. Let's get to the second half, where he discusses electrons, but not a theory of what holds electrons together. Others along those lines, well, again, there was Picasso, who was looking for a new art form. And what he found was the way to do it was to push what Cézanne had done into extreme geometrization, in which he was inspired by science, mathematics, and technology. Now, as for finding connections between disciplines that don't appear to be connected, Einstein, again, is classic at this, in that he realized that there was a connection between the axioms of thermodynamics, which have to do with heat, and the notion of space and time. How does that have anything to do with space and time at all? Well, at that time, there were a class of experiments which were very difficult to understand on the basis that the speed of light varies depending upon the relative velocity of the laboratory with the source of light. To Einstein, the axioms of thermodynamics offered a means in that they were axioms, and so they were to be accepted as true without any experimental or theoretical proof. Just take them as they are. And so this led him to axiomatize that the velocity of light is the same to all observers, and that's it. And that took care of a lot of these experiments, which seemed difficult to understand. It didn't explain them, it just eliminated them. And so Einstein's theory was not a theory of explanation, it was a theory of description. Another example, a nice example, is a man named John Carlin, who worked at Bell Labs in the 1950s. And that was a time when telephones were making the transition from a rotary dial to a punch pad. And so what is the optimal design for a punch pad? Well, people looked into it from a physics point of view, an electronics point of view, but Colin pointed out, let's look at it from a behavioral aspect. He had his PhD concerned behavioral sciences, and the optimal keypad was something that would be behaviorally convenient to the person using it, not just scientifically convenient. So he found a connection between the behavioral sciences and electricity, essentially, telephones.
You're listening to The Science of Creativity, a podcast about art, design, and invention. If you're enjoying the episode, I hope you'll subscribe to the podcast and rate the show and leave a comment because it helps people like you find the show. You can find The Science of Creativity on all podcast platforms. Oh, that's interesting. So if you were just a technology person, you might not even worry about putting the numbers in order. 1, 2, 3, 4, 5, 6.
Yeah, he outlined something that is still the case today on mobile phones.
Right, which it sounds like that's an example of your interdisciplinary creativity.
Oh, very much so. I mean, all great discoveries emerge from interdisciplinarity.
Right. The combination of two existing things to make something new.
Right, somebody pulling in knowledge from a large number of areas.
Right, so all creativity is some combination of two existing things that are in the mind. So then your mind puts those two things together, and that's where you have inspiration.
Right, which is, of course, one of the components of creativity is inspiration. You might say, can machines have inspiration? Yes, they will in the future.
Right. Is there any similarity to what goes on in our everyday lives? You know, we're not Einstein and we don't work at AT&T. Do we have our own sort of everyday conceptual combinations?
Sure, there's what's called little c creativity, everyday creativity, finding a better way to drive to work, for example. Then there's big C creativity, domain busting creativity, which it's not an even C. Some people are smarter than others. And some people are super smart, sometimes called geniuses, which is not a PC notion to be used any longer, but they are. They can understand things and do work in a studying over a smaller amount of time than other people. They catch the essence of things. They catch the big picture. And the big picture is what's important in creativity. Great scientists, for example, don't worry about whether there's a minus sign or a plus sign or a cosine or a sine. They hover over like drones. They hover over the forest and can see the forest for the trees.
Right. That leads me to a question I was thinking when I was reading your book, is that your career has focused on this big C creativity. You tell great stories about famous individuals through history. So why is it that you chose that path to study big C creativity instead of studying smaller C creativity that everybody has?
Well, I think through studying big C creativity, you can understand little c creativity eventually. And what's paradoxical here is that theories of psychology and theories of creativity are formulated from interviews and from tests with small c creativity people. So let's study big C creativity, and maybe we can come upon a better way of looking at creativity in general. There are 7 properties, 7 hallmarks, as I call them, of big C creativity. We might talk about one of them is introspection, and that entails several aspects. It entails looking inwards, thinking about what you're thinking about, and to do this, you should make time for reflection. For example, relaxation. You should sit in a comfortable room, in a comfortable chair, and think about the problems that you're working on. And this brings out another aspect of introspection, namely unconscious thought, which is a very powerful component of creative thinking. Most of our thinking is done unconsciously, but the intense, passionate desire to solve a problem keeps it alive in the unconscious, where if you're walking down the street thinking of something else, your brain is still working on that problem. And then the illumination can occur. And then that illumination percolates up into consciousness for the verification phase. But the initial phase of all this, conscious thought, is necessary. Intense, passionate desire to solve a problem.
Oh, that's really good. I'm glad you brought up your 7 hallmarks of creativity, because I thought they all sounded like good advice, like things that we could all get better at. And you just mentioned that the first one is introspection. So what is the role of unconscious thought in that introspection?
Well, the role of unconscious thought is to keep a problem alive in the unconscious. Think about that problem as a famous person in ad creation, John Hegarty said, when do I do my best thinking? When I'm not thinking. In other words, your brain is always, there's something always going on. I mean, you can wake up in the middle of the night and suddenly, when suddenly a thought pops into your head, which is a solution to a problem that you've been thinking about. We've all had that, for example. There's the so-called tip of the tongue phenomenon. When you're walking down the street and suddenly the solution to a problem, or you suddenly realize who the person was who you were just speaking to. Your brain is working amazingly quickly, running through its entire database of names and faces and finds it. Much like a machine runs through its entire database. When it's thinking about a problem, and machines do think, they solve difficult problems, and the word for that is thinking. So there is a similarity, essentially getting off course here, but there is a similarity between us and machines.
Oh, that's a great transition, actually, because your book, 2019 book, The Artist in the Machine, and the subtitle is The World of AI-Powered Creativity. And you were way ahead of the curve. When a book is published in 2019, you wrote it in 2017 and 2018. So the way that these programs create, so we talked about big C and little c creativity. Which one do you find in machine learning in ChatGPT? Is that big C or is that little c?
It's both. If you give a prompt to it about a problem you're working on, it could be, what's the best way to drive to work? It will give you a reply. And it could be also, it's working towards big C creativity. Occasionally it has big C creativity. Well, one occasionally, actually, that machines can be creative was undoubtedly shown to be the case in 2016, when AlphaGo, an algorithm invented at DeepMind, which runs on an artificial neural network, trounced a highly regarded Go master. I mean, that was a wow moment for AI. Stocks went way up. China considered it to be their Sputnik moment. And then there was AlphaGo's successor, AlphaZero, which was even more amazing. Whereas AlphaGo was fed 30 million board positions, taken from games played by Go masters and then played against itself zillions of times to improve its game. AlphaZero was fed only the rules of Go and chess, and then played against itself to hone its game. And the game it plays is highly, highly unconventional because it had no contact with humans during its training period. So it makes very weird moves. But the weirdest move was made by AlphaGo in its second match, I should say. It played against Lee Sedol, the Korean Go master. It was move number 37. And when it made it, the team from DeepMind, as well as the Korean Go master, Lee Sedol, thought the machine had hit a glitch. But as the game went on, something weird was happening. And sure enough, in move number 87, everything snapped into place. And it was clear why the machine made move number 37. And the machine saw 50 moves ahead. And at that moment, Lee Sedol thought about resigning from the game. So machines can see and imagine what we cannot imagine and see. And then the successor using AlphaGo's architecture is the machine AlphaFlow, which predicted all possible structures for proteins. And it won a Nobel Prize for Demis Hassabis and somebody else at DeepMind. So, yeah, machines can solve big C problems. Machines can have intent also, the intent to finish the program. What machines can't do right now is, although people are working on it, is to come up with a fundamental problem. That it hasn't done yet. But it does use, to a small extent, it works in an interdisciplinary way. I mean, I'm a techno-optimist. There has to be, guardrails, of course. And my comment to people who have all sorts of outrageous suggestions for machines and outrageous criticisms is that give them a break. They just came into being, and what they're doing is amazing. It's so amazing. Most people have come around to this now. There's something in large language models that have many, many layers of artificial neurons that goes beyond numbers and probabilities. Emerging qualities such as creativity and possibly consciousness too. So machines are definitely creative. And of course, they will be more creative than us because they have a bigger database than us. But one of their values for us is for us to collaborate with them so that our creativity and their creativity is bootstrapped. And so we can enrich and enlarge our pushes on the frontier of art, literature, and music.
You've said that one of the key hallmarks of creativity is this ability to identify good problems and ask good questions. That's one thing I've often thought about Gen AI is that it's the human user who's asking the question, and then the Gen AI is responding, so that the Gen AI isn't as good at identifying good new problems.
Not yet. No, not yet. And quite right. We put in the prompt, and the machine moves on and creates a reply. Similarly, we put in a prompt, and an art bot creates a work of art. I think the situation here is not unlike that of Leopold Mozart and his son Wolfgang Amadeus. The father taught the son the rules of composition, but we don't attribute the music, the son's music, to the father. Similarly for machines. The machines are working on their own when they're let loose. But yes, they haven't discovered problems as yet. But they will.
Right, right. And that sounds like an example of what you said, collaboration between the human and the machine.
That's big right now, yeah. And it's been extremely helpful for both. Well, I haven't used the machine for writing plays, but
Oh, yeah.
but people do. Some authors also put in the paragraph on which they get stuck, and then the machine moves on. And sometimes the suggestions can be good. I mean, machines could do some amazing things in playwriting. And in a group I belong to in London, actors and writers, they have a competition to write a 10-minute play. And plays that are chosen are acted out on stage at one of their meetings. So I wrote a 10-minute play on AI. It didn't get chosen. Second try didn't get chosen either. I know what they want. They want rom-coms. I can't do that right now. But at any rate, so I asked ChatGPT-4 to write a 10-minute play on AI, and I gave some characters. And it did it. It wrote a 10-minute play in 3 acts, no less, and it had magnificent stuff in it. I also wrote a book, Einstein Picasso, parallel biographies of Einstein and Picasso when they were young men, and the 50th anniversary of Picasso's death came along, and I felt I should do something. So I just, as a lark, I asked ChatGPT-4 to suggest something, and it suggested a book, and not only it suggested like 12 chapters in detail. And it said I should focus on Picasso's thoughts on the fabric of time. Now, it should have been the fabric of space, but that phrase, the fabric of, is quite extraordinary.
All right. One thing you say in your book is that the machine learning, the Gen AI algorithms are creating in very much the same way that people do. Did I get that right?
Yes, in the sense that they take into account all accumulated knowledge, just as we take into account all accumulated knowledge and work from there and create something else. And we can define creativity as the production of new knowledge from already existing knowledge. And the process occurs by means of problem solving. And that's precisely what machines do. Well, again, right now you have to input the problem. But machines can verify presently. They can verify mathematics. They also make funny mistakes when they verify mathematics. Sometimes that's called hallucination. And that's a technical problem. It's being worked on, but you don't want to completely eliminate hallucinations because after all, hallucinations can be creative. We think of, for example, Samuel Coleridge, who wrote Kubla Khan, hallucinating under the influence of opium. but machines, there's nothing wrong with machines hallucinating. As for racial and gender, machines are sometimes unjustly accused of being merely autocomplete devices, but so are we to some extent. To the chagrin of our friends, we annoy them with completing their sentences sometimes in the course of conversation. And as for racial and gender biases, well, they're there. They can be eliminated. There are technical ways of doing it. But there, too, you don't want to completely eliminate them because there's a certain amount of playfulness that's involved. And playfulness is part of creativity. And who is to say who is to clean up the web and how? So there are problems that bounce back and forth in this whole business with AI ethics.
That's an interesting point that people are like Gen AI in that they're trained. So you think about, let's say, your Bach's student, and he's teaching you how to compose. So your compositions are going to be pretty similar to Bach's compositions. So you could think of yourself as an AI being trained by Bach. Is that kind of what you're getting at?
You can do that. That was a big deal. Around when I wrote my book, there were several people like David Cope. I don't know whether that name means anything to you.
Yes.
Yeah, and he was a leader in that. But I mean, I interviewed him. I had a long discussion with him about it. I mean, Bach has already been done by Bach. You don't want to do that again. And also, it's not really Bach. It's not really excellent Baroque music either. A trained musician can know immediately that is not Bach. And no pleasing melodies, as far as I know, has ever come out of that sort of thing. But yeah, there was a big deal going on to compose in the style of Bach or paint in the style of Picasso. But that's already been done. You want the machine to do something new. Right now, AI music is still, I think, lags behind AI art in its aesthetics at any rate.
There's something I discovered, I guess it was about 2 months ago. I like certain kinds of Korean independent music, and I found a playlist on YouTube, which I really liked. And I saw a little note down in the episode notes saying that it was generated with non-human content. So I
Right.
went
Yeah. Yeah.
looking into it. I discovered the entire playlist had been generated by a computer. And I thought it was really good. So I felt bad about liking it, but I
It
keep it.
can be, and one runs into all sorts of social problems here, and a lot of people are going to lose their jobs. On the other hand, indie films, for example, can use non-copyrighted AI generated music, and some of it is pretty good too. But on the other hand, for example, when fast food came in, fast food is easy to prepare and so on and so forth. So it really took over. But then there was a reaction to it, to cook your own food, to be make believe that you're a chef. And similarly with AI, there may be a reaction to that also, in that to prepared music, in that there will be a movement back towards human composed music, human composed art. But that's not going to last forever. There will be, I see, three strands of art in the future. One strand is artists working on easels, oil painting. They'll go by the wayside. Another, collaborations between machine and human, and then art produced by machines. Now, the point is here that we are merging with machines, and we are in fact already machines. So biological machines on one level, chemical machines on another level, elementary particle machines on a deeper level. But to say emerging with machines is something else, because that means chips in the head, chips all over the body. Now, it's difficult for us to imagine what our descendants will be like 1,000 years from now. They won't look like us. They won't think like us, and certainly not with chips in the head. What their conceptual framework will be, we cannot even imagine. But we can speculate anyway. It is often said that one cannot predict more than 5 years into the future, but you can look into the deep future, 1,000 years, 10,000 years, 1,000,000 years, 1,000,000,000 years. And by that time, we will have populated our solar system, and we will have made excursions into other galaxies and maybe into other universes, traveling through wormholes in which we could traverse in seconds trillions of miles. But I mean, just to speculate a little bit more on a science fiction story, there'll always be the home planet from which maybe all communications emanate. But in about 5 billion years, we'll have to evacuate this place, because our sun will be in its dying throes. It will die as a red giant star, a superheated bag of gas that will cook everything in its path, including where we are. And there'll be nothing left but a barren rock. There'll be no indication that anything ever went on here. So our descendants by that time will have hopped into starships, gone into another star system, another galaxy, another universe, find a planet, a congenial planet, alight on it, begin to populate it, and there will be new creation myths, and history will begin anew. Now, these new creation myths will begin by some combination of chips and what we were. And so their creation stories will be very different. There will be by that time what we may call androids, sort of like the replicants in Blade Runner, and we will be cohabitating with them, and they will be like us. We will live with them and populate the universe, and perhaps and eventually as just one species.
Right. Those creation myths are going to be written down, and from the beginning, they're going to be stored in a computer. But the ones we have go back so far in history that they predate literacy. So they were oral traditions.
Right.
I don't know if that makes any difference with what's going to happen on this other planet.
There'll be new creation myths, because there'll be new people. What is human? The notion of what is human will be, radically transformed. And similarly, the notion of what is artificial will be radically transformed. And indeed, the line between artificial empathy and, in quotes, human empathy will blur, and there will be only empathy.
Right. I wonder how that relates to your 7 hallmarks of creativity in your book, because those are the ones, it seems to me, we get some purchase that we can take them and become more creative. And you mentioned the first one, which is introspection, and you gave some advice. You could sit back in your chair and not try to think so hard. And then I'm looking at the third one is don't be afraid to make mistakes, to focus and persevere. Don't be afraid to make mistakes. So that's something we can learn to be better at. But how does that fit into a computer? A computer doesn't do that thing, right? They don't make mistakes and then build on the mistakes.
They can make mistakes. There's a very interesting paper written a couple of years ago when ChatGPT 4 just came out, and this group at MIT, the AI group at MIT, were doing tests on the original one, the one that had not yet been perfected, and they gave it the following problem: multiply 8 times 7 plus 9 times 5. And what is the answer? So they asked the machine, what is the answer? The machine gave an answer, and then they said, is this correct? The machine said yes, but it was wrong. And so they took the machine step by step, and then they got another answer, and the machine says, this one is correct. And then the group said, well, but you said the other one was correct. And the machine said, oh, that was a typo.
Right.
They all laughed. The machine just came up with it. Yes, machines can make mistakes. You give it a fundamental problem. All the data might not be there for it to consider. And the idea, creative people are willing to make mistake after mistake after mistake, failing each time better and better. As Niels Bohr, the great atomic scientist, put it, an expert who's somebody who's made all possible errors in a given domain.
Right.
So, but you should try to create and not stop you. As Picasso put it, creation is everything.
Right. And then when people are doing it, these failures, they become iterative, right? You have a failure, then you recognize it's a failure, then it gives you an idea for the next step, which may or may not be a failure. Do you see something analogous in generative AI?
If I understood your question correctly, generative AI will fail better and better. More and more data will be incorporated into it. At this stage, I mean, this is still an elementary stage, and that data has to be input into it. But however, let me add this. Recently, a Gen AI solved a math problem using concepts that were not on the web. Okay, so it invented, however you want to put it, these concepts. So the Gen AI, in certain circumstances, need not have all the data necessary to solve the problem.
Right, that is fascinating. No, I wasn't familiar with that. I'm going to jump ahead to another one of your 7 hallmarks of creativity, and I wonder how it fits in with generative AI, and that's the 6th one, which is thrive on ambiguity. And that aligns with my own research into art and design, that they will say things like, you need to learn to live in a world of ambiguity. So is there some parallel with generative AI? Does it thrive in a world of ambiguity?
Some of the problems it works on, I mean, not that many creative thinkers can thrive in a world of ambiguity.
That's right.
Looking at history of quantum mechanics in 1925, nobody understood they just gave up. Nobody understood the atomic world. As the great physicist Wolfgang Pauli put it, he was thinking at that time of going into films. There was a real problem. Heisenberg was somebody who thrived in that milieu, and he succeeded in discovering quantum mechanics. A lot of people had been working on it. He built on some of their results as well, but they weren't getting anywhere. They were becoming more and more confused. Similarly, with the uncertainty relation, he also thrived in ambiguity in that area as well. With machines, again, we'll have to see how that works out. But I'll bet that they will be able to thrive in that world because they will have a huge amount of data at their disposal. In fact, all the data that exists in the world on the problems that they're working on. But they seem to have a certain flexibility in the way that they think.
Right, absolutely. And then I'll move on to the 7th of your 7 hallmarks of creativity, and it's another one. I'm not sure how that fits in. The need for experience and suffering.
Okay, well, machines aren't suffering right now. That's one of those things where I would say, give the machine a break. It has very narrow limitations. No, it's not suffering right now, but it does have experience in the sense of having a lot of data at its disposal. But certainly, suffering is necessary for if you have a romantic view of creativity. The second one on this list, the need to know your strengths, I think is interesting too. because the need to know your strengths means that you don't fritter away your time on subjects that you're not very good at. For example, Einstein had the choice of going to mathematics or physics, but he realized in mathematics, as he put it, he would be like Buridan's ass. He would be confronted with problems that he would just didn't know what to do with. But in physics, he could find his fundamental problem. And Heisenberg had a choice of being a concert pianist, of being a physicist, but he felt, even though he was a superb piano player, that he could achieve more in physics. So yeah, that's that's a very difficult thing to do, to know your own strength, to focus on it. I mean, it's sometimes said that people in their quest to be the all-around person fritter away their time when they should have been focusing on a particular aspect of problem solving.
Right. It's better to be specific.
Right.
And that's what I'm always telling my graduate students in a PhD program, because their PhD research proposal is always to do something huge and impossible to do in an entire career, much less in a PhD dissertation.
Well, one always has grand thoughts when one is a young graduate.
Right. It's a good thing. No, I always tell them it's good that you're thinking this way, but you won't finish your dissertation until you get more focused.
Right. Yeah.
So be specific. That's it. And knowing your strengths. In my own case, I was always a good pianist. And in high school, I thought about applying to music school and becoming professional. And then I realized, no, I didn't think I was quite good enough. So I went to MIT and I majored in computer science. And I was good at that. So I still play piano, but I have to realize I'm really good at this thing I'm doing, and I wouldn't be that good at piano. Right. But in your case, you actually, maybe not music, but you've been very successful as a playwright. And would you say that you feel like in your mind, when you're creating a play, is it similar to when you create in other ways, like even physics?
No, so it's really totally different. You're sitting in front of a blank screen, and you could conjure up a world of your own, where you're essentially the puppeteer. You can move these people around. You give them dialogue, so it's very different from doing theoretical physics. What's interesting, I found interesting. This may sound trivial, but the day goes so fast when you're writing a play or writing a story. It just moves right by.
It sounds like that flow experience, when you're having that peak experience, then you lose track of time.
Yes, you do. Right. And the editing, then you go through an editing procedure, and you go through 15, 20, 25 versions. And again, you're moving around people. The way the theater works is that you write a play. You have words on paper. You write stage directions. And then when it comes on stage, you have a director. And the director, in a sense, breathes life into it, makes the transitions between scenes into something that you didn't expect before. And I think it should be a process in which everyone works together. And indeed, in my play, Synchronicity, the director, myself, and the two actors had discussions, and I would sometimes, as the case often, rewrite on the spot. And that's the way a play comes into being all the time. First is the script, then the director comes in and gives suggestions and makes the words come alive. And some writing and rewriting is necessary.
So your play, I saw, it was just produced and it was on stage last month. So I'm going to ask, well, what are you working on now? What's your next project?
My next project is I'm writing on AI, and I have a play which is going to go into production. I'll tell you more about it next time. And I'm also writing a play on AI.
Oh, that's fascinating. And will the AI be a character in the play?
Oh, yes. Well, it will take place a few hundred years in the future, even going beyond a few hundred years. And there will be machines that are people, are androids, people in the transformed notion of what a person is, of what personhood is.
Right. How about characters?
Yeah, there will be characters. They will be part of the landscape. There'll be, in quotes, human characters and replicon characters as well, and reactions to them. I found most of plays about AI are written by people who don't know anything about AI. They know what they read in the papers, and so they're not usually very good. There are a few notable exceptions, but mainly they're not very good.
Well, good. Yeah, I do look forward to that. Well, we are coming to the end of our time, and I always like to end by asking if you can give a suggestion or some practical advice, something a listener could do in the next week that might enhance their creativity?
Absolutely. I've thought about this. And I think, first of all, practice mindfulness. Be in the here and now, no phones. Seek new experiences, of course. Make time for reflection and relaxation. Bring that unconscious dimension, catalyze that unconscious dimension of thinking. Brainstorm by yourself, in other words. Reach beyond your grasp.
Oh, that's wonderful. That's going to be the title of our episode, Reach Beyond Your Grasp.
Very good.
Well, thank you so much for joining me today. It's been a great conversation.
Oh, thank you, Keith. It's a pleasure.
That was my conversation with Arthur I. Miller. His lifelong quest to understand creativity bridges art, science, and now artificial intelligence. You can learn more about his work and his books, including The Artist and the Machine, at arthurimiller.com. And thank you for listening to The Science of Creativity. I hope you'll share the episode, subscribe to the podcast. It really helps spread the word. Thank you for listening to The Science of Creativity. If you liked this episode, I hope you'll subscribe to the podcast, and please rate the show because that helps others like you hear about the show. Please write in the comments if you have requests or ideas for future episodes. I'll see you next time on The Science of Creativity for insights and inspiration about art, design, and invention.